Hey everyone, and welcome to today's Explainer. Today we're diving into designing for greater efficiency. Now, while the broader topic covers both water and materials, we're going to focus our lens entirely on water today. We really want to see exactly how targeted building decisions can directly impact some of these massive global resource crises. It's a pretty wild journey from the planetary scale right down to the plumbing hidden inside our walls. So, let's get started.
Okay, let's dive into this with a paradox that we've probably all thought about at some point. If water covers 71% of our planet, why exactly is water scarcity considered one of the defining crises of the 21st century? It feels like a total contradiction, right? We live on a blue planet, yet we're facing unprecedented shortages. Well, to really get it, we've got to look past the surface and understand how water actually moves, how we capture it, and critically, how we use it.
So here's our roadmap for today. First, we'll look at the global water crisis. Second, how buildings use water. Third, we'll uncover a hidden cost in the water-energy nexus. And finally, we'll wrap up with designing water-efficient systems.
All right, jumping right in. Section 1, the global water crisis, understanding planetary risk. Take a look at this map from the World Resources Institute's Aqueduct platform. It's honestly a pretty stark global risk assessment. The World Economic Forum actually ranks water supply crises as one of the absolute highest impact risks facing our entire planet right now. Notice those severe red and yellow zones dominating massive population centers in Africa, Asia, and parts of the Americas? These aren't just historically dry areas, these are regions currently facing extremely high overall water risk. Our whole management strategy really depends on location, because all the water we use comes from rainfall that feeds rivers and groundwater aquifers. But as you can see, the amount available varies drastically.
And when we analyze global precipitation trends, things get even more complicated. We're seeing regions dealing with simultaneous floods and droughts. The overall global trend right now is that wet areas are getting wetter and dry areas are getting drier. But here's the crazy part. The result has been almost no change in net precipitation globally. What's happening is that when it rains, those rains are getting heavier, and they're immediately followed by much longer dry spells. It's these extreme whiplash swings that are intensely stressing our global water supply.
Let's move from the global map right into your daily life with Section 2, how buildings use water, the anatomy of consumption.
In a typical middle-class home, perfectly good, highly treated drinking water is being diverted for a bunch of different purposes. When you break down the usage, faucets take up 23%, the kitchen is at 18%, flushing water closets or toilets accounts for 16%, and general washing and cleaning is 11%. It really kind of forces us to step back and ask, do we honestly need highly purified drinking water just to flush our toilets or water the lawn?
But here is the massive, crucial takeaway. Almost a third, 32% to be exact, of all drinkable water entering a home goes straight down the shower drain. When you analyze a building's projected water use like this, it's like a giant puzzle, and you immediately see where the biggest wins are possible. If we can just target the shower and the faucets, we're already tackling over half of a household's total consumption. It's huge. Now, water use varies drastically by building type, so the way we measure and manage it has to adapt, right? A home might use 270 kiloliters per unit per year, primarily for bathing and cooking. But a hotel, that's measured completely differently, at about 180 cubic meters per room per year, with bathing as the clear heavy hitter. Meanwhile, an office building measures efficiency at around 64 liters per day per person, with almost all of that going straight to the washrooms. This means an architect's efficiency strategy can't be one size fits all. It absolutely has to be heavily customized to the specific typology of the building they're designing.
Which brings us to a really fascinating twist. Section 3, the water-energy nexus, the hidden cost.
You see, saving water isn't just about preserving H2O. There is this remarkably strong connection between water and energy use, known as the water-energy nexus. Basically, energy is a prerequisite at every single stage of the cycle. Think about it, from municipal purification and treatment to the massive distribution pumping required to push volume across a city and up to the top floor of a commercial high-rise, right down to your domestic heating systems. It all takes power. So the aha moment here is that more hot water use inherently means more energy consumption. When you conserve water, you are literally lowering a building's carbon footprint and energy demands at the exact same time. It's a total dual victory.
So how do we actually do this? Let's get into the solutions with Section 4, Designing Water-Efficient Systems, the Architect's Toolkit.
We can organize our engineering solutions into 3 clear, straightforward steps. Step 1, simply reduce the demand for water right out of the gate. Step 2. Recycle the water you do use, maybe utilizing systems that treat gray water from sinks or even black water. And Step 3. Harvest local natural resources, like capturing rainwater right off the roof. If you just keep this rule of 3 in mind, reduce, recycle, harvest, these highly technical design strategies suddenly become incredibly clear and easy to implement.
And to actually achieve those 3 steps, we deploy specific technologies. Stuff like low-flow plumbing fixtures, efficient water closets, and auto shut-off faucets totally nail the reduce phase by preventing needless flow. Then, moving to the next phases, systems like condensate water recovery and water-efficient landscaping allow us to capture, recycle, and really maximize the water that's already present on site, so we aren't wasting precious treated water on the grass. The beauty of this approach is that the savings from each individual system stack up to a truly substantial amount of conserved water and energy over the entire life of the building.
All of this leads to a super encouraging fact straight from our source material. It is not difficult to reduce the water usage in buildings with existing technologies. I love that. We do not need to sit around waiting for some miracle invention to solve the water crisis in our built environment. The tools, the fixtures, the harvesting systems, we literally have them in our hands right now, ready to be deployed.
Which leaves us with this final thought. We've seen those severe risk zones across the globe, right? We understand the hidden energy costs, and we know that the tech to fix this is already sitting on the shelf. So knowing the massive global stakes, how will you redesign your next project's water footprint? Every single building is a fresh opportunity to be part of the solution. Thank you so much for hanging out with me for this explainer. Keep learning, keep designing efficiently, and I will catch you next time.